Let me set a timer for myself so you don't feel like you have to jump in on me, Max. I'm very excited. Thank you to Binta and Max for inviting me. I feel like I'm mainly consuming today. This has been really interesting. I can't say, I feel like there's a lot of things for me to learn in this space. When I talked to Max about doing this, I think what I'm going to try and do today, a little bit, I think, similar to some of the talks we've seen today, is first, I think I want to kind of try and outline some of my thoughts on this in maybe a way that economists and me as an economist at least have approached some of this. I think there are economists in the audience who might feel differently. Certainly, Abby, feel free afterwards if I feel like I'm not potentially representing the views of economists correctly, but give a little bit of a sense of how I'm thinking about some of this, and then talk about one of my pieces of work in particular, just to give an outline of, I think, where some of this work is going and hopefully what can be done in the future. So what I took as a launching point, which was really helpful for me, is, Abebe and Casey really have this nice paper thinking about just decision-making, algorithms, unfairness. And there was this one line in it that kind of stuck with me from the introduction of this concept that many leading notions of fairness, such as predictive parity or balance, are based on some variant of the question: are members of different groups who are of equal, quote unquote, merit treated equally by the algorithm, right? So one thing that I thought was very interesting about this, so it's obviously a totally reasonable setup about this idea of predictive parity or balance, or just fairness more generally, is one could have written this sentence as: are members of different groups who are of equal merit treated equally by society, the market, judges, firms, the government, right? There's nothing special inherently to the algorithm, other than obviously that this was published in a computer science journal. And I think the authors would be very aware of that. They're kind of trying to make this clear to the computer science audience. But I thought what was kind of interesting was to try and highlight what's sort of unique about the concerns about algorithms. I think what prompted some of the discussion in that paper is that this point, it's a very easy kind of pitch, is to say, look, in both academia and in popular press more generally, there's just this unique concern about the rise of algorithms and data and the extent to which machine learning is playing a role. That's the whole reason of this conference. And I thought it would be helpful to kind of highlight what are two unique features of algorithms. So one that is, I think, unique about the growth of algorithms from a fairness perspective is that algorithmic decision-making process kind of makes the subtext text. So what I mean by that is almost a little bit of Josh's point about a causal model makes things explicit, but it's kind of really important. Is you have to specify your inputs, how you manipulate said inputs, you get the outputs, and the more automated the process is, the more explicit this decision is. There's just not wiggle room in the same way, which I think that isn't inherently any different than any decision-making process, but what algorithms have done is sort of forced us to make this very explicit in the way that we talk about it. At least that has been my sense from part of what's come out of the discussion in the ML space. And then the second point is by sort of specifying what are the relevant inputs. So what Abebe and Casey talk about as merit, and it can show up as a lot of things. It kind of starkly outlines what the objective function is too. Kind of here are the inputs, here are the things that we're saying, we're taking in, we have the objective function that's going to take those inputs. And Abebe and Casey kind of describe this as this narrow bracketing, this idea that, look, there's this very particular thing that we're focused on when we do this decision making. And it treats the inputs as what I would call as an economist as exogenous or fixed from outside the model, which is kind of interesting. It's like a flavor of so much of what shows up in the discussions that we're having, but an economist it's kind of like the bread and butter here. And so what I think is a good thing. This is not meant to be like this is already something, it's to say, look, we're having this debate and it's obviously extremely important, this debate about algorithmic fairness and discrimination and inequality. In some ways, this is just kind of a debate about societal fairness and discrimination, full stop, right? There's in the sense that all we've done now is just made these things extremely explicit in a particular context. And the reason I'm kind of saying that is that economics, to some extent, has a rich history of, I would have said, tackling, but stumbling through these questions is maybe a more fair way of saying this, in the sense that, like, thinking about these decision problems, not so much from a purely algorithms-based perspective, but from a market-based perspective, it's kind of has a rich history in econ. A lot of it sort of started and sprouted from the labor market. So, really trying to think about discrimination along race, especially in the labor market. But it's been, most of these ideas have been ported to other subfields. So in my subfield of household finance, this shows up a ton when thinking about consumer credit for obvious reasons, like kind of the same questions of who can get a loan are just as important of who can get a job. Gary Becker's book, so this is a picture from its cover, from he kind of coined the concept of a taste for discrimination. This book, Economics of Discrimination, this idea of a taste for discrimination, how it would affect the labor market. So all you really need to know in this context is this idea of that there's a set of racist, sexist, or what Lang and Lehman call prejudiced employers. So there's something, they're prejudiced in some way that are willing to lose out on a profitable opportunity to satisfy their bigotry. And the idea is that, if you write down a model that looks like this in equilibrium, depending on what large a share of the employers are prejudiced in this way, that it's going to create a wedge between whatever the discriminated group is and the other one. But what's kind of important to highlight, and I just want to say this, and then hopefully kind of the contours of what I'm trying to get at with showing these econ models will come clear, is that that's a model that was very explicitly written down by Becker here, and sort of shows an equilibrium setting. There's an objective function, there's a decision that's made by the employers, and sort of we have all the output that comes out of it given inputs. And then the question becomes, well, what's the interpretation? And one of the big interpretations that always got pushed here was, well, the market here kind of makes it so that employers are potentially going to lose out on money because they're just doing this to satisfy their own needs. And then as a consequence, what's going to happen is that they are going to lose money. And so in the long run, they're going to kind of go out of business, was always this thing. And so Heckman has this very nice quote from his 1998 paper saying, that's not necessarily the case. You take this model, market discrimination is not necessarily going to disappear in the long run. Entrepreneurs can consume their income in any way they see fit. So he makes the analogy between, if you want to be bigoted, it's the same thing as buying a really expensive kind of ice cream, right? So it's just you're spending your money in its own way. It's only if you then start to talk about other pieces, so that are further down up the road, which is that, if the supply of entrepreneurship is perfectly elastic, and what he means by that is that if there's just people who are willing to come in because it's very cheap to become entrepreneurs, to become employers, that then it's going to drive people out of business, and because they can't spend that money on expensive ice cream, they really have to go all the way down to the budget ice cream, and they can't be prejudiced. Or if there's just enough non-prejudiced employers. And so what I kind of want to highlight is that in this book, fairness or equality is kind of presupposed, at least in one measure of it. Everyone is identically productive. And so the one objective function we think about, this marginal productivity, there's just everyone should be treated equally under the guise of this. But if they were not, then the model would say, oh, well, of course you'll pay this one group less than others. There's nothing different here, distinctive here. So this is all in the lens of a very simple model. But what becomes, as research kind of unpack this, is this highlighted this fact that, well, the Becker model really assumed that workers know who discriminates and who does not. And so Black has this paper in 1995 that shows that, well, when this is relaxed and workers have to search for work, for example, the pay gaps emerge even when there's lots of non-discriminatory firms. And that's because the victims of discrimination have a worse outside option. And so they don't know who in the audience or in the pool of employers is racist or is sexist or is bigoted in whatever way. And so as a consequence, they don't know who to go to work for their real marginal product. And so by definition, they just are a worse negotiating position. And so the non-prejudiced employers take advantage of that. So that's kind of, at a very high level, that's one version of how economists have thought about these types of models. And that is useful insofar as it kind of frames one way in which economists have thought about fairness. It's the idea of, well, are there just people who inherently are bigoted or prejudiced or whatever else? This other one is for the statisticians and computer scientists in the audience. It's probably one that starts to look a lot more familiar. And it's this one. So Ainer and Kane is the paper I'm going to talk about. They're not kind of the canonical paper. Phelps is kind of the canonical paper, but they kind of argue that this is kind of a much cleaner version of the model. And really what they talk about is this idea of statistical discrimination, which frankly, I think is a pretty uniquely economics term. And I don't mean that in like a nice way. I think it's like we're the one, I think any normal person on the street, you tell them about the statistical discrimination, they would say that sounds like discrimination. And I think legally that's the case. If there's any lawyers in the audience, they may know better. What I basically just want to give you a sense of is this is a model, written 45, 50 years ago. And what they're saying is that imagine that there's an employer who wants to know how productive you are. So there's some productivity aspect or merit, Q, and they only see some signal Y, which has some noisiness associated with it. And so you want to infer what Q hat is given the data. And so, what you would write down in a very rational way is, well, there's some shrinkage that's going to occur. There's the data we see, and then there's the average. And because we have this nice normality, we're going to shrink towards the mean. That's sort of the efficient thing to do in the posterior. And what you can show is that if you have different groups, then if different groups have different noisiness and different levels, you can talk about, okay, well, there's different productivity levels, but then also different qualities of the signal. Hopefully this is all starting to sound very familiar. And that basically what ends up happening is that there's this point of that you can have very different types of market outcomes that depend on kind of how employers are viewing the signal and what the relative signals are. The issue that came up and that comes up in the debate about these models, this has been happening for decades, is what is discrimination? So in economics, it's almost understood, I think this perhaps is changing. I know that sort of Max would maybe feel differently, is that discrimination based on Q is potentially viewed as problematic. That would be the thing that we wouldn't want to do. We wouldn't want, if two people are equally productive, we shouldn't discriminate on it. And that's kind of how we've defined discrimination in this setting. So what happens in this is that with equal average productivity, so this means that they're shrinking towards the same thing, but one group is noisier than the other, then what happens is that the group with higher noisiness will be shrunk more towards the average, but the overall average wage will be the same across groups. And this is kind of what you can end up showing is, well, that means kind of there's not going to be an average difference across them. There's going to be kind of differences in noisiness and how things are viewed, but the average wages across groups will be the same. What happens, and this is hopefully what I'm starting to build on, is that these things break as you start to change parts of the model. So now you make firms risk averse and you say, well, firms don't want to have a unluckiness of getting a bad draw from the distribution of who's unproductive. And so then the risky firms are less likely to take on the people who are harder to predict. And so that's going to create these kind of wage gaps. I'm kind of summarizing very quickly, like a big literature that happened over the last couple of decades. But what I want to use it to highlight is that there's been these big debates of how should we even think about fairness in this? Is it, they have this view, they're talking about exactly this risk aversion issue, is that this reflects a hypothetical model, of course, but it's consistent with our view of reality in two important respects. As a consequence of actual employer practices, economic discrimination against Blacks, women, and other groups does exist, resulting in group differences in pay despite equal group abilities to perform the job. However, if the definition of ability includes reliability in test taking on grounds perhaps that aptitude conveys useful information to employers, one could deny that economic discrimination exists. And so this is their words, not mine, but it's kind of what I think is useful about this is that they're kind of highlighting how do we think about what we should be discriminating on, the inputs, the outputs, what's the fairness criterion. And this is the last piece of kind of overview of modeling that I want to say here, which is that an important question in that model I just showed you is this idea of, well, where does Q come from? I just told you there's this thing, well, there's this Q signal, meritorious aspect of it. We want people to be of equal merit, equal productivity is what we have in the labor market. The question is, okay, well, what's Q? Where did you get Q from? And so in labor markets, one natural thing is to say, well, how much schooling you did, like how much did you invest in yourself, what an economist would call your human capital. And so Lumberg and Starts then propose endogenizing this choice of schooling. So what endogenizing means is rather than taking it as fixed, let's go up a level and say, well, where does the schooling come from? So what they are highlighting, going back to that model we just looked at, is saying, okay, well, given that there's a noisier signal from schooling for one group versus the other, there's actually less incentive to invest for one group than relative to the other. This is true even when the groups were equally good, whatever good means, quote unquote, before the schooling decision. And you can see that basically here in this prediction problem, right? So Y is the signal on the x-axis, and what the predicted Q is on the y-axis. You can see for the group that's Black, because they're noisier and they're being shrunk more, this is basically measurement error, that the returns of investing in your Y is lower. And so there's maybe less value in investing in it. This was kind of what I wanted to kind of highlight here, is that the features that we take fixed or exogenous are the core features for how we interpret the discrimination and fairness. I think many of the people here agree with this, but what's really helpful that I wanted to kind of clarify is that I think the more that we think critically about the features, the more that there are important features outside the model that drive them. And so how do we trade off on them? And so I have this picture here, so it's turtles all the way down, right? So the problem that shows up, and every economist and probably every person working on these problems says is, well, okay, I'm worried about Q. Now I'm going to go endogenize Q, but then how did I get the stock of things beforehand? And it's this constant problem of, well, what are the trade-offs and where are we thinking about these things? And so I'm not saying anyone has gotten them right, especially amongst economists, but I want to kind of highlight the big feature that economists have spent a lot of time thinking about. And as I say on the title of this slide, is that the sales pitch for economists as co-authors, assuming you can take the rest of us that goes with economists, is this idea that economists have spent a lot of time thinking about the equilibrium component of it. So equilibrium matters a lot in these models that I've been describing. I've been describing it at a very high level, but there's this idea of, okay, well, in the steady state, sort of what is occurring? Is there entry of entrepreneurs who would drive these things out? What do we need to assume? And how is information aggregated by the people who are looking at this? And my argument would be ignoring these features can have unintended consequences. And implicitly, what I'm suggesting is that in the literature that thinks about discrimination and inequality in these spaces really needs to be careful about, well, what's the implication when we think about the new equilibrium after we've changed something? So a good example of this would be, I'm going to show you two examples, but kind of this idea of when we think about policy changes or how we evaluate algorithmic decisions, it's useful to think about them in the context of whatever market or setting we have in mind, because it may have unintended consequences. Let me show you two examples. One is going to be very short, and then one is going to be from my own work. Let me check my, I'm fine on time. So the first is an example, not from my work, but it's actually in the context of employment. So employers in the United States, I'm not actually sure in the UK or in Europe what this is, but employers in the UK can ask job applicants if they've been previously convicted of a felony initially on a job application. So you submit something, there is a box that you check, that you say whether or not you've been convicted of a felony. There's basically a literature kind of showing, using audit studies and other things in the sociology space, that shows that this knowledge basically is a major impediment to employment, or at least to callbacks. And Amanda Agan and Sonia Starr have this paper from 2018 that's showing that banning the ability to ask this question, so this is ban the box, so banning the ability to check this mark, whether or not, so you're not sending this information anymore, causes basically a pooling that goes in sort of a downward way for Black applicants, and is actually kind of fixed, or it seems to uniformly benefit white applicants. And so just as an example here on the right, this is a graph from their paper. This is like figure 4, where what they're doing is the following. They've sent audit studies to firms. So they've said, send a bunch of applications. In this context, it's resume audit studies. So they're doing names that presumably are sound, representative, Black American versus white American. And what they're showing is that when prior to the law change that happened in New York and New Jersey, there were differences in the callback rate. So this is after they call you for your first round interview. So how many were called back? So 8% were called back if they had checked the box amongst Black applicants, and 13.4% if they had not checked the box. Whereas after the law was banned, it's kind of pooled in the middle. And for white applicants, it kind of went the opposite. If anything, it pooled effectively as if they were all non-crime. And so what a model of information and statistical discrimination in line with what I have described would suggest that there's some prior that these employers have for Black applicants. Now, whether or not they're right is kind of beyond the point in this, and that clearly it sort of had these consequences. One key implication, right, is it's not unambiguously good, especially for Black applicants to ban the box. They're presumably the Black applicants who had not committed a felony would prefer to have the box there. But obviously for the ones who did have a felony, they're much happier about it in the sense that this information now, removing that was good. So it was very heterogeneous in terms of who was benefited. So a kind of a key point that I want you to take away from this is two aspects. One, there's clearly this potential unintended consequence. And then second is that there's this substantial heterogeneity within groups of who's a winner and who's a loser. Even when we're thinking about disparities across Black versus white, there's this within racial group heterogeneity that potentially matters quite a bit. One kind of longer way that I want to talk about it is my own work, where I've tried to think about this, thinking about credit markets. So in credit markets, we kind of are trying to highlight that there's big distributional impacts even within groups rather than just across groups. And so this is work that I've done with Andreas Fuster, Tarun Ramadore, and Ansgar Walther. And in this paper, I'm going to give you kind of a very short version of the talk, is that what we're really interested in, and I think this doesn't need much motivation for this audience, is we're saying, look, there's been an adoption of kind of more sophisticated technology for predicting certain types of things. So one central application for prediction that we'd obviously care about in the finance context is thinking about default prediction. And what this paper is really trying to think about is, well, what are the distributional effects of new technology? And so we do a lot of stuff in the paper. It kind of, you can break it out into kind of four pieces, where the first one is kind of a very simple theory point. Theory is almost too generous to say that just think about when you improve your statistical technology, what's kind of the distributional implication of improving your technology? And it's very easy to think about when you improve your ability to predict, there are going to be potentially winners and losers relative to whatever your counterfactual was or whatever you're comparing it to. We then actually apply two prediction techniques to actual US data, to administrative data in the United States, looking at mortgage default. And then we look at these distributional consequences, both in prediction and in the context of a lending model. So I'll try and just walk through that now, just in a relatively quick way. So what I want to kind of highlight, and this is going to give you most of the intuition for how we're thinking about what we think is why we find the results that we do, which is to say, look, when you're a lender and you're predicting something, so I'm really taking this very simply, we're not being very critical in analyzing the objective function or anything else. We're just saying most lenders in any kind of profit maximizing model would like to minimize the mean squared error of the prediction of default. You might even write it down that they're trying to maximize profit, but inherently minimizing the predicted default rate in a simple model is pretty close. And so they have some set of characteristics X and some default outcome Y. And what you can think about is to change from an old technology, which is a restricted class of functions. So for example, you could imagine that the predicted model is linear, which is obviously pretty trivial, to a predicted class of models that provides, basically allows for a wider class of permitted functions. And the sort of simple point that hopefully makes sense is that the optimal predictions with the new technology that is moving to a wider class of permitted functions are going to be a mean preserving spread of those with the old technology. Just the idea that we're going to nail things more correctly as long as we're sort of looking at the best predicted function within each class. They're going to be winners and losers is really the implication. And one really easy way to see this is just graphically. So you could say, look, here's a univariate prediction problem. We're saying there's something like FICO score or income on the x-axis. So we imagine people who are high income are less likely to default. We have default on the y-axis. The initial model is to say we're going to only let it be linear, just running a linear model with regression. And the more complicated version would be to say, all right, well, let's let it be nonlinear. So we're going to say quadratic. We could open the space to be quadratic. These are obviously very simple examples. But the key point of it is here to say, well, let's look at the relative winners and losers in this setting. So what it looks like is that amongst the folks who are close to the mean, so the mean is A here, that the change for their predicted default rate is going to be lower for these individuals. They're basically predicted as being lower default probabilities, whereas the folks out on the extremes are predicted to be higher default probability. So there's this, because of this convexity in the new technology, those at the extreme are going to lose and the people on the interior are going to gain. Well, what does that imply? If you just think about there being two groups, like a blue and a red group, then, what you can think about is that this is going to have differential impacts on one group versus the other. So the blue folks who have a wider variance, even though on average they're the same, there's going to be more winners amongst the red group than there are amongst the blue group. This, I think, is not a super difficult thing to think about, but what it means is that as you allow your functions to be more flexible and you change from one regime where things are potentially less flexible to more flexible, that this is going to cause there to be just inherently some groups that are going to win versus lose just as a function of the distributional features of those groups. So what we're going to do now is kind of with that idea in mind is we have a pretty cool data set where what we're using is a linked data set of Home Mortgage Disclosure Act data to McDash. So McDash or Black Knight is one of these mortgage default data sets where kind of what they're pooling together. If anyone is in the audience has ever tried to work with mortgage data, the problem with the Home Mortgage Disclosure Act is it's very useful for kind of seeing originations and seeing information about race, ethnicity, gender, but it gives you squat for underwriting characteristics. So if you actually want to kind of measure the riskiness of these individuals, almost nothing about them, that things that a lender would typically look at. And you also don't know how it performs. And so this linked data set lets us do both. It lets us say, well, what are the underwriting characteristics of these loans? And how do they do subsequently? What's the predicted default? Or what's the subsequent default for these loans? And so we're going to have a big data set of about 10 million mortgage loans over a 5-year period, where we're going to be measuring default as being 90 days delinquent within 3 years of origination. So what's interesting in this data is you can kind of just look at you can see in the end some features that are potentially unsurprising, and some features that are surprising. So one, perhaps surprising or unsurprising. So in this data set, the default rates, there's pretty significant variation here. So Asian and white non-Hispanic borrowers tend to have the lowest 3-year default rate. White, Hispanic, and Black borrowers tend to have the highest. And their FICO scores of the borrowers in the population kind of tend to reflect this. So FICO, for those of you who don't know and aren't stuck with the vagaries of the American credit system, is a measure basically provided by credit bureaus to measure the riskiness of borrowers. That's using kind of a wide range of data. Think of this as kind of a predicted metric already provided to some lenders. And what you see is that Asian borrowers have the highest, Black borrowers have the lowest, kind of consistent with the default rates we see in the data. But the one feature that I do think is very distinctive that is in line with this distributional point that we wanted to make is that also the standard deviation of these underlying credit scores vary substantially, kind of inversely with what we just talked about. So amongst Black American borrowers, the standard deviation, hence the variance of FICO score, is substantially higher than it is for Asian and white non-Hispanic borrowers, in such a way that there's going to be much more dispersion along that dimension than it is for white non-Hispanic borrowers. The last thing is just that, related to these kind of average differences in default, we also see average difference in interest rates that correspond with this. Borrowers are very aware of this feature. So what we do with this data is we say, let's do the following, which I think is perhaps very unnecessary given this audience. When I always tell finance and econ audiences when I present this paper that I can pretend like I'm doing something sophisticated, but this is very off the shelf relative to things that are actually being done, where all we're really trying to do is think about probability default. It's a binary classification problem. Historically, if you had gone 15, 16 years ago, thinking about this in a simple logit model would have been really kind of the default practitioner or academic thing to do. If you think about around the financial crisis, I worked on a lot of stress test modeling. Doing lots of covariates in a logit model was the cutting edge, in at least amongst the folks who were doing this work. Whereas kind of now there's a much better understanding of there's these off-the-shelf methods, either using decision trees in kind of a random forest setting or using boosted models like XGBoost to try and do these classification problems. So all we're really doing is we're saying, let's do 2 prediction models. One is a logit that we're going to fit using training data. And the other is going to be this random forest model. This stuff looks very similar if you use a boosted model as well. In these logit models, we're going to kind of, I don't think it's totally relevant for the audience here, but we're going to be thinking about a lot of inputs that you could think about, well, should we even think of these as being exogenous per se? We're going to take them as exogenous. So things like income, LTV, FICO scores, the origination amount, et cetera, a number of characteristics here. I think there's an important question on whether or not what should one condition on. But in this context, we're just going to be kind of doing the suite of traditional underwriting measures that somebody would use. Kind of the punchline here is twofold. One is that we do kind of the standard thing. We estimate this on a training set. You evaluate this on a test sample. You find that you can do better with these kind of ML models. Strikingly, you don't do that much better. In part, this is just like we don't have that much new data relative to other settings. We basically our R squared is about 15% higher, and we see that it's kind of a significant difference between the two of them. So what that means is kind of the random forest model is a better predictor of default than, say, this logit model. And it's true across a wide variety of kind of settings. What's more interesting in this setting, and one thing that's worth highlighting is that it does particularly better when you don't use this FICO measure, which, as I mentioned to you, is kind of the thing that's provided to banks. They say, hey, we've already done all this analysis for you and we've put people in a line. Here's a measure you can use. Obviously, if you plug that into another model, that's going to help you quite a bit. But that aside, kind of one of the most important features in this setting is that what we find is that those folks who are looked as more creditworthy, the percent share of folks who look as more creditworthy in the random forest model versus the nonlinear logit model, is that disproportionately folks tend to look more creditworthy. So you tend to have a lower predicted default rate under the new model than under the old model. But almost all of those gains are in the context of the white non-Hispanic and the Asian American borrowers. So those individuals tend to just look more creditworthy. So if you think about the optimal prediction, it's just shifting more towards 0 or something closer to 0. And that's true it's kind of remarkable how much this is true across a variety of things, which really suggests kind of the gains are accruing to a particular group. The last thing that I want to kind of say is that, that's interesting in and of itself. And I do think that is something that we could have kind of stopped there. I want to kind of argue that one useful thing that we at least can highlight in this, and this is not perfect by any means in an economics model, but you can take these results and then say, well, imagine now we had a competitive equilibrium. So we're going to make loans. And so this is a very economics jargon to do this. But all I'm saying is now I'm saying there's a bank that is competing with a lot of other banks. They are trying to make loans and they're competing with other banks. And so they know kind of how risky people are. People come in with a default set of characteristics X, and we say, all right, we know given that X, kind of what's their probability that they're going to default. Given that, what is the, we're going to vary the interest rate and find the interest rate that makes it such that given that person's characteristics, what is kind of the loan that I can give them that won't keep them from going to another bank? And so in a competitive equilibrium, what an economics model would argue is that basically the net present value has to be 0. We have to be charging someone an interest rate such that we're not going to make any profit on it. The reason being that if we make some profit, then another bank is going to come in and undercut us and charge a slightly lower interest rate. You can make that more complicated, but that's the idea. And so what we're going to do is we're going to say, all right, given the loans in our data set, what's the interest rate we would charge all those people we see in given our predictive models, and who would we not give loans to? And the people we would not give loans to are those where we can never find a loan where it's worth giving them one, where the NPV is negative. So hopefully that's clear. I want to pause. I know that that is like a lot of econ jargon all at once. If anyone is unclear on that, let me know. Conceptually, all I really want you to take from this is we're just thinking about if we were doing a very stylized model of an economics model of making these loans, who's going to get the loans and what are they going to be charged? And how does it vary as we go from the nonlinear logit model to the random forest model? Okay. We can calibrate it. That's not very interesting. The kind of key point is that this first, if we look at who's getting loans, it's very kind of consistent with what you would imagine, which is, look, acceptance rates, that is people who we give loans, goes up as a share of our data set. The reason for that is under the new model, we can kind of do a better job of evaluating who's worth giving loans to. So two people who were getting kind of pooled together now are separated. We can do a better job at evaluating the risk. And so we give a loan to the person who it's worth giving the loan to. And worth giving the loan to, I mean that purely from the profit maximization standpoint. And so what we see is kind of across the board, acceptance rates go up, which is very consistent with the prediction of a model of something that's slightly more efficient. Importantly, though, is that we see, for example, that the average spread at origination, which is the interest rate charged on the loan, goes up for Black and white Hispanic borrowers under the new model, but not for white, non-Hispanic, or Asian borrowers. So the implication there is that they were being pooled in some way, and now they're basically separating, so the average interest rate is higher. And then lastly, there's much larger spread in interest rates. So this new technology is basically increasing the dispersion both across and within groups in the interest rates. So these are relatively large. I mean, these are relatively large increases in the spread, in the standard deviation of the spread of origination. We basically see something like a, I want to say a 30% increase in the standard deviation of the spread at origination for amongst Black borrowers. So kind of the punchline of this is twofold. So one is that, you know, you can use, this is a very stylized way of approaching this, but if we take real data, we apply these kind of more flexible techniques, we see that there's this greater predictive power, there's gains for producers in the sense that they're able to more effectively differentiate who's risky. But based on the data that we see, kind of there's a group that bears larger changes, Black and Hispanic borrowers. There's this first moment effect, which is that they're more likely to be perceived as high risk, but there's actually even just this larger effect, which is this increased dispersion of outcomes within a group, which I think is in line with, for example, some of the concerns raised by Max's paper as well, which is this idea of thinking about within group dispersion inequality and sort of focusing just on the groups themselves is maybe not the first order interesting thing. Well, I didn't talk about it today, but this comes from more than just the idea of like putting in race dummies. So obviously it's not legally allowed. And if there's any lawyers here, they'll sort of know in the US context, you can't do that, but that doesn't seem to really drive a lot of our results here. But the last kind of most important piece is that if you put this in a competitive model, just because Black borrowers look kind of higher risk, or they don't really gain at all, there's big extensive margin gains. So they don't necessarily look riskier, but they're better able to differentiate kind of how to kind of extract, you basically the elasticity of the probability of default with respect to interest rates is more effectively measured. And so lenders are more willing to give loans. And it's kind of interesting that these unequal effects kind of seem to persist at the intensive margin. So in my last minute, so this is what we took from this. Hopefully you see that this is kind of consistent with that very short version of this ban the box point, which is to say there are winners and losers. There's winners across groups, but there's also winners and losers even within these groups that we historically have cared about. I had all these other things that I wanted to say, and I obviously didn't have time for them, and I couldn't figure out how to put them in my slides. So I figured I'd put these up here as a food for thought if there are conversations that people want to have. But what I just want to highlight is, I'm not suggesting that the econ way of approaching this is the right way to do this. I think there's a lot of debate within economics about what is kind of the right thing. For example, my view is, why do we care so much about documenting the type of discrimination? I highlighted these two models, which is taste-based versus statistical discrimination. It's not obvious to any normal person why one would care about distinguishing there. An economist might say it's, well, because we want to figure out the right policy tools to intervene with in order to do this. But in the research space, we might maybe stop fetishizing so much about what type of discrimination it is and more what are the interventions. There's this question I think that I've come to terms with a little bit is it's very easy to think about these economics models as being positive in the sense of not normative, but it's very clear that it's insidious in how much they kind of end up being normative in some ways in terms of what we treat as exogenous and what we treat as endogenous. I think that Josh kind of got on this. I come in a very different perspective. I'm very much of the non-manipulable. You basically no causation without manipulation, but it's still challenging, which I think Josh and I would both agree with in the sense that it's really hard. And so causal inference is important to think about here because it's hard. And then the last point that I just want to highlight is what is the equilibrium? What's sustainable? And if we're going to propose changes or diagnostics, how do we identify the benefits and costs for businesses and society? All right, thanks. I went a minute over. Sorry about that.
Thank you. Who wants to go first?
So there's one question from the audience that asks about the error rates. And in your paper, are there error rates that are similar across groups? You're muted.
Sorry, all I said was that's a good question. And then I looked off into space. So we do some, I'm trying to think about, so we have, I don't know the number off the top of my head. I have to imagine within, I don't know. I'll just say I don't know and I'll just look. It's a good question. I have to imagine that there's some amount, simply because the data is so much sparser in the, for the minority groups that we're studying, sort of white borrowers are such a large share of it that I have to imagine there's at least some, but that's a good number that I should know the answer to. I'll tweet it since I'm not, the paper is already published, so there's no way for me to publicly post this information, but I will tweet it. So that way someone, whomever you are, I'll try and find out the answer.
Abby, do you want to go next?
Yeah, it's kind of a related question. How do you deal with the fact that we don't observe outcomes for people who don't get loans, or can you observe people getting rejected in some banks and then getting loans in others? And then also kind of, this is a bit random, but when you were talking, it's kind of a related point that when we're making these technologies available in a market, it often feels like we're thinking about one firm acting in isolation, whereas actually what's happening is potentially lots of firms are then introducing these types of technologies. And I was just wondering if you knew anything about the kind of IO or like these kind of, yeah, it's like you're changing the outside option. When these things get introduced, it's not just your chance at one firm, but it's likely to become more correlated with your options in others. So yeah, but yeah, thanks for the talk. It was really cool.
Yeah, totally. Let me do the first one kind of because it's not the answer to your first question is not very satisfying. So we'll do that quickly and then move on to the one that I can have a more interesting thought on, which is about this labeling problem. So this is, it's this issue of we don't see people who are rejected. We don't deal with it in a way that I think is as satisfying as we would like. And so in terms of taking these as purely causal estimates, I think it's very challenging. So there's two pieces. So one is, are the estimates, how much are you being basically biased and kind of, are these causal predictors of it? Because you're not seeing the people on the extensive margin. One of the things that we try and do is we just kind of do an imputation. We do see people who are rejected, but we don't know, for example, the default outcome for them. So we can think about the accept reject margin for a lot of these folks using imputing data, but we're assuming a very strong kind of missing at random thing when we do it. What we do for the calibration for thinking about the equilibrium is that we look at the estimated sensitivity of default rates with respect to interest rates. That's kind of the big one that matters for estimating the decision to make loans. And we basically have other literature that we compare it to kind of adjust what we found in there. So it's a slightly higher sensitivity than what is estimated in the data. So my co-author, Andreas Fuster, has a paper where what they do is they exploit interest rate resets and looking at the effect that that has on default rates. And the idea is to try and use that to recalibrate a bit what happens. But I think the problem in these loan cases, and people who work on this will be aware, is it's doubly problematic. It's not just the kind of the labeling problem of being released or not, for example, in the bail or the parole example. You have both the decision to make the loan and then what interest rate they were given. So it's kind of this continuous valued problem. So I think we pretty much threw our hands up and we're like, this is a best first approximation, but it could have serious issues. To your second one, the IO thing, no, there's not really any great work on this. There's obviously, one could think about the following. So I've talked to Thomas Philippon at NYU about this. If you just thought about one firm being the first entrant with this technology, you could imagine a very different equilibrium than what we described, which is for the non-economists, you think about the cherry picking version of this. So the cherry picking version of this would say, all right, well, forget about, just NPV of 0. What you'd say is all of you were making loans using the old model. You were doing 0 NPV things. Forget that. I'm going to go in. I'm going to find all the people that you guys are actually worth lending to at even lower interest rates, but you don't realize that. But now I have new technology. I can figure out who's really worth making loans to, and I'll go and make loans to those people. This is the cherry picking story. This is actually what happens, for example, with student loans. If you're a student, somebody with the student loans in the United States, the federal government keeps everyone at a very similar interest rate. Private firms come in and they cherry pick. So this is with a model. So one could imagine a model where you start thinking about the dynamics of how this competition happens. I don't really know above and beyond just kind of the thought experiment what I've done, in part because it's hard to know what are firms actually using for these things. There seems to be big heterogeneity in it. Places like JP Morgan Chase are not really doing anything too complicated. I think mortgage markets are probably the worst place to study it because there's so much institutional infrastructure in place. For the dynamics aspect, I think it's useful for the thought experiment, but it's not useful for this particular exercise. Credit cards or auto loans would be a much more fruitful place to look at it. Yeah, good question. Sorry, I should have changed movement thing.
There is a question from Martin.
Yeah. Hey, Paul, thanks a lot for the talk. That was great. So I was thinking in the credit rating example, you said that it also creates a lot of winners and losers within groups. And that made me think of kind of interpretability of these different algorithms, right? Because for a simple logit model, I at least as a human can still understand what's going on while the machine learning thing is just a big black box. So I was wondering if I should care about interpretability here in order to know what's going on.
Yeah, and that gets a little almost to the where's the noise and where are the differences. I had a figure that I took out from when I typically present it, which is trying to think about, say we take a slice of like a two-dimensional part, hold a lot of the characteristics hold a lot of the characteristics fixed, and then look at kind of the isoquants of predicted risk and what these look like for the logit versus say the nonlinear model, for the random forest model. I guess I wonder, so I'm not an expert in this field. I have wondered about, my sense is that it can kind of change a lot. Like, I wonder how stable these things are. And maybe this is something that I haven't done, is if you did the interpretability thing, how much, and I don't know, maybe you know better than me, Martin, is like, how much would these things change if you went from one sample to the other? Presumably some of the stuff would be stable, but maybe some of the things would be less so. I guess I don't
especially
have a
if
good
you have correlated predictors, right? Then it becomes almost arbitrary which one you include, say.
Yeah.
And so it can completely flip around depending on the sample.
Yeah, is this I mean, this
essentially the same.
Yeah, so I guess that's a big question of like kind of, this is sort of similar to this irrepresentability problem in Lasso, right? Is like, how much are these things correlated? Okay, so yeah, so maybe that becomes, but that's probably more of a, I don't know if that has a philosophical aspect or if it's purely just a statistical problem. And like these things are all capturing from a causal standpoint, to kind of Josh's point, is that there's a true thing that we should be measuring, but we're not actually measuring that. And so as a consequence, that's why it's kind of has these features that Max just described.
Yeah, but wouldn't you think that this still, that we should still take that as maybe the simpler model therefore is preferable sometimes, because it does create less noise and it kind of makes it easier for us to know what's going on?
Yeah, I don't know. I mean, the thing that I struggle with in this, and I haven't spent as much time thinking about kind of the right thing to do in these debates about normatively what is the right thing to do. It made me think I should do more of thinking on that. But I think there's a lot of people who want things that are not black box. Certainly regulators. When I talk to people at the OCC or at the CFPB, I think there's a lot of concerns about the black boxiness, maybe in part for the reasons you described, Martin. Also because there's all these legal ramifications. So I guess tomorrow we're going to hear more on the law side, but this becomes a huge issue of how do you decide what restrictions are going to be put in place. And so, yeah, I think that's a hugely problematic issue with a lot of these kind of more black box prediction algorithms. I know there's a lot of folks who are trying to make these things more transparent, but I'm not at the cutting edge on that. I don't know if there are others who can speak to that.
I guess one aspect is that a lot of the algorithms are private anyway, right? It's not like you have access to most of the algorithms that affect decisions about you. I mean, also kind of going to the point you're making at the beginning. Yes, in principle, we get the counterfactual decisions of these algorithms and we know how they work and so on. But in practice, we don't have access to the data. We don't have access to the algorithms. So it's not clear we have this transparency either way.
I mean, it's striking. What is interesting is that I think what would be, so to this point, actually, is a little bit, I know sometimes it feels like we don't have access to anything, but at least on the bank side, what I can say is that we also used to think that we wouldn't have a lot of the types of data that we see. So if you post financial crisis, the kind of data that the Fed got access to amongst the biggest banks, now we don't see it as part of the public sphere, but it's from a regulatory standpoint, it's kind of unexpected kind of what you get. And so the extent to which people who work on algorithms can say, look, as a regulatory body, you need to, like, there needs to be a drive to do this. I think that there is appetite for that in the regulatory space. I think you'd have to make the case for it, but you'd also have to have the technology and the know-how in the regulatory body to be able to study this stuff. But I don't think it's out of the question, at least in the United States.
But maybe also ask an interpretation question about your talk. So I guess in a way, the band box example is probably the easier version of what you were talking about. But I guess in a way, I always found it confusing that people seem to interpret the paper as saying that, this was just a failed policy because it didn't reduce between group inequality. But in a way, we wouldn't expect it, right? Like we would expect that if you have an observable group membership and we reduce the information available to employers, then yes, the spread of their prediction is going to go down, but not the between group inequality. But it is very much going to reduce within group inequality. And I guess depending on your viewpoint, it might be a good or bad thing. But in a way, we would probably think for a lot of settings that, I guess, going in the opposite direction, as you add more information, you kind of mechanically get a mean preserving spread of predictions, at least for Bayesian predictors of means. And so that is mechanically going to increase inequality within the groups that we observed beforehand and not affect between group inequality. And so, I mean, at least to the extent that the things you're predicting are positively correlated with pre-existing inequalities of social status, we would think of this as a bad thing in terms of welfare inequality or kind of social welfare consequences. Yeah, and then I guess the kind of equilibrium effects which complicate it, but.
Yeah, I guess, so you're making the point kind of about, like, say we're going to add things. It's kind of I mean, once we do it in that direction, it kind of has these points. One thing that I like when I put that down, and I was wondering if this was something that wanted to describe, is like, it is interesting that we take it as so obvious that, like, what the group membership even is. Like, there's an element of, like, why do we know what the group membership, I mean, these models are like, okay, well, there's group A and group B, and obviously you're going to shrink towards group A. And it's like, well, you know what?
It's like, I think early 20th century US, if you're Irish, you're not white, or if you're
Italian. Exactly. I mean, I think there's good sociological work about this of, like, what is the out group and what is the in group in many contexts, and it's going to vary based on. I mean, I don't need to say this because I'm going to butcher whatever a sociologist would actually want to say, but conceptually that it's very context driven. So I do think that that's interesting. One thing that I would just say back to your point about the information removal. You know, maybe it's obvious to an economist or to, like, somebody, it would be like, yes, it's going to have this effect. But I think many policymakers it's very hard to sell someone on the idea that this is going to happen. One thing that I have this other paper, which is thinking about bankruptcy flag removal on credit reports. And so there was this literature, this is sort of similar to the ban the box, which is saying, look, when you file for bankruptcy in the United States, it's a mark, it's a negative mark that goes on your credit report. And so then that is eventually removed. There's basically this forgiveness of things that negative things that you did, eventually they fall off. For bankruptcy, it's 10 years. And basically there was a lot of pushback post financial crisis or after the Great Recession, like we need to not let employers use credit reports because it's preventing people from being able to get jobs. Now, this is a couple papers in this. My paper in particular, though, was saying it really doesn't seem to have much of an impact on people's ability to get jobs. At least the employment rates are near identical, as are the wage bills. And that's not to say that whatever. I mean, this is just a version of ban the box that says actually the elasticity with respect to that information is almost zero, which is just, right. That's just this is an irrelevant predictor. But it's meaningful because it's like in some contexts, it just doesn't matter as much, whereas it obviously seemed to for the criminal measure. Anyway, it matters for the credit setting. If you get rid of your bankruptcy flag, immediately you get like within 2 years, you get $3,000 worth of more of credit card limit. Like your banks are falling all over themselves to give you a credit card, but it doesn't have an impact on the job finding rates. Anyway, I agree with you. I think the information part of it is a piece that we don't do in this paper because we don't have an empirical analog, but that's the kind of more interesting question is if you widen the data set, you have more features that you can add. What is that going to do? And how should we think about within and across group inequality? Anyway, sorry, that's a lot of thoughts.
There's a question from Michael.
A question about the causal inference issue that you raised in the food for thought part at the end of the talk. It's always struck me as odd, the idea that there's no causation without manipulation. And that's in part because maybe I misunderstood what's being claimed, but I mean, that would suggest that until we had people manipulating variables, there were no causal processes operating in the world. That didn't happen until we came along. So this is more philosophical, but it seems to come up in these discussions a lot. So I'm wondering, have I misunderstood the claim or have I had something wrong? But it just seems like an odd claim, given that we think causes occurred before there were people manipulating variables. I guess that's the question.
Yeah, I mean, I'll give my attempt at sort of the version of I have the thought, and I think I don't think you're alone in your view of it. So the issue that I have in it is what I find challenging about, for example, thinking about it in the race context or the no causation without manipulation is I typically think that it is just hard for me to think about if you can't think about a world in which you would change the feature, that then I don't see how to sort of envision what that world would inherently be. Just sort of conceptually, so if we take gender and race are kind of loaded in terms of thinking about this, but I just think inherently that what one person thinks of as the manipulation of making someone, for example, the female version of me or something else, that's going to vary a lot. And so what we have in mind more is that there are certain features that are potentially manipulable or that we're thinking about changing, which is the way that society perceives me or something else that we have in mind. So I don't think that I'm saying that there aren't things that are causal. So for example, without humans being around, like you could imagine, I'm thinking of the causal effect of like, the slope of changing a roof and the way that kind of snow will fall off it or things like that, things that have nothing to do with humans being around or the things we manipulate things in nature. If those are randomly permuted, I think of those as still being like causally affected without humans being around. So maybe, I don't know if I'm doing a particularly good job of explaining myself, and maybe Josh, you want to have an opinion or jump in and sort of elaborate relative to Michael's view on it.
So the way I think about this limitation is I think it is really useful for people who really want to design experiments and really want to analyze actual data sets. And then like the reason why I allow myself to go away from this restriction is because I also sometimes want to think about like toy models. And I see those toy models as like diagnostic tools. Like it's definitely an oversimplification of anything like a real data analysis, but I think it might be sufficient for understanding like something that might be important about the real data analysis as well. So like, yeah, another idea here, I don't know if anyone else uses this terminology. I like to think of deep counterfactuals and shallow counterfactuals in terms of especially like the perception of supposedly non-manipulable characteristics. So like if you do an experiment where you change perception of someone's race or gender by changing the name on a resume, I think of that as a shallow counterfactual. It's an experiment that can estimate the causal effect when, basically of the perception of race or gender on a resume. It does not tell you a deeper counterfactual, like what is the causal effect of the composition of a person's resume, like all of the other factors that have happened in their life before that point that might also influence other aspects of their resume. In particular, like we know that the same causal effect of perception is there at earlier stages in a person's resume building process, because like one of these experiments was done on assessing applicants for like a lab manager position, and then other experiments are done at like the faculty hiring stage. And so by the time someone's reached the faculty hiring stage, they might have already been affected by the perception of their race or gender at the earlier points in time. So I also I think it's sometimes useful to kind of cross this notion with the dimension of time and think about the depth of a counterfactual being how far back in time do you want to think about this change having occurred.
I don't know if that gets,
yeah,
sorry. I don't know if that fully gets at it, but like for me, I think that I'm more in line, Michael, with your view on it than against it, in the sense that I don't think it has to do inherently with humans manipulating things, but more the issue that I'm taking is just that I can't envision sort of a lot of the terms. I mean, I think relative to the conversation has to do with this idea of, I don't view it as conceptually a thing that one can manipulate. Race is such a social construct that I find it challenging to think about it in that setting. That's, I think, all I was trying to say in that particular view.
I think the old econometrics terminology is kind of useful here. It's calling variables exogenous, right? When they're like generated somehow from outside a system. It doesn't have to be intentional manipulation by any agent that's around. But if, I don't know, a meteor hits the Earth and it's coming from outside, and it's also a manipulation in a wider sense.
Right.
Ruben?
Yeah, just briefly to add some more terminology. So I like this distinction between deep and shallow counterfactuals, and the philosophers who use counterfactuals to talk about modal logic, for instance, they talk about possible worlds. And so counterfactuals obtain in possible worlds that are different from the actual world. And there's some sort of pseudo geometric notion of distance between worlds. And so you can think of it in that way as well. I don't know if that's useful for actual causal modeling though, but my guess would be nearby possible worlds are like what Joshua called shallow counterfactuals, and far away possible worlds are ones in which perhaps we would decide that. So I don't know if Paul's reasons for not buying the no intervention, no causation without intervention one is to do with just the sort of epistemic gap between the actual world and far away possible worlds, or if it's some other thing. But it's an interesting potential kind of discussion that could be had.
Right. I mean, I'm happy to keep the discussion going, but otherwise you could also wrap it up for today, since we have another 5 talks tomorrow.
Yeah, well, thank you very much, everybody, the panelists and the attendees, for these 5 hours of discussion, and looking forward for the next 5 hours tomorrow. It will be mostly on law and a bit of computer science. But yeah, we hope to see you again. It will be the same link, and it will be also the same setup. We'll have also the YouTube live stream going on for those who can't join the Q&A. But yeah, So thank you very much, everybody. And looking forward to seeing you all tomorrow.